class, welcome back to the Streams Lab. Now this second part of the lab is looking at three major U.S. rivers. We'll be looking at the Missouri River, Arkansas River, and the Mississippi River. And mainly what we're going to be doing here is filling out this table here, looking at these topographic maps that I've put on there. These maps that I've put on Canvas for you, I don't want you to print them. I just want you to look at them on your computer. And so let's see how we're going to work these out. So we'll have the map up here. So the first river is going to be this Missouri River at Leavenworth, Kansas topo, and that's this river here. For this part of the lab, I'll be writing on the sheet here, and we're going to ask some questions, and we'll be going back and forth between the sheet and the topographic map. Again, for this exercise, you will need a string. So I have my string here, and you'll have to measure or lay this out along the course of that Missouri River. And I'll show you how to do that once we get to there. So the first question is asking us to look at whether there are any meanders, any back swamps, any oxbow lakes, or meander cutoffs. So when we look at the map here, we'll see that I do see a big meander here. I see what appears to be an older oxbow lake down over here. There are floodplains, but I don't really see the back swamps. Remember, so in this case, the width of the valley here, the stream valley, is the meander belt. So this looks like a stage 2 stream. So looking at the document camera here, so you would just answer yes, there are meanders. There are no back swamps. I did see a oxbow lake here. And for meander cutoffs, remember that would be an example where we're seeing a meander being cut. And I don't see any in here, but I can tell that they've happened before, because if Mud Lake here is a meander, then the river cut that off. So I would say that since I do have an oxbow, and really by definition, if you have an oxbow lake, at some point there was a meander cutoff. So let's say yes for this one as well. Now for the gradient, we want to measure really between the 765 foot and the 755 foot contour lines that I've outlined on the map here. So you want to take your string and lay it across here and along its winding path all the way down to here. Then we'll see how many, we'll stretch it out on this bar graph here and see how many miles it is. So I'll do this on my map here, and then you can compare it for your answers. So let me do that next. So using my string for measuring along this distance, I get about 14 miles, 14.2 miles. And so again, I was using my string, right? So all I did was I placed my string along the path of the river, and I got 14.2 miles. For our gradients, remember our gradient is going to be the change in elevation, which in this case we're seeing from 765 to 755, that's 10 feet over the course of 14.2 miles. Then we just do the math there, and we'll say 10 divided by 14.2. And so it's 0.7. So it's a very low gradient stream. It's dropping less than a foot per mile. So 0.7 feet per mile. That's your answer, 0.7 feet per mile. And that's what you want to do. You want to do the same thing for the Arkansas River and eventually as well the Mississippi River to do that same sort of distance. And I give you the distances. You'll see on the maps where those locations are. For example, let's look at the Arkansas River Royal Gorge map here. And in this case, I'm asking you to measure from this point here, the 5,600 foot contour, and you'll place your string, make it go all the way down here, down to the 5,400 foot contour. And this map is a little bit, has a different scale. Note that the bar down here, this is 4,000 feet. So one thing you'll have to do for this map here, so in fact, let's kind of look at what's going on with this one. For the Arkansas River, note that our bar scale, in fact I'll put it up here, is that the bar scale is 4,000 feet, right? So what you need to do, you need to convert that into miles. And we know that for every mile, so in 1 mile, there's that 5,280 feet that I have right here. So basically you're going to take that 4,000 divided by 5,280 feet, and the feet will cancel out and your answer should be in miles. So do that to give you what that bar is in miles. So we can just do it real quick here. We'll take our 4,000 and divide it by 5280. So that's 0.75 miles. That's easy enough. So on our Arkansas map, those 4,000 feet is 0.75 miles. So now you know. And I think for the Mississippi River, so down on this map, we see that it's 10 miles down here, right? So this map has a 10-mile scale. All right, so you should be in good shape to complete those. Now the next thing we need to do is kind of answer the sinuosity here. So in this case, since we already measured the curvy distance, so for our sinuosity here, we have those 14.2 miles, right? So now what you want to do is measure the straight line. So on that map, for the Missouri River, just take or you can take your string or a ruler and just measure the same distance here and figure out how many miles it is on the map. So I'll do that next. So with my string, I measured the distance here and compared it to the scale down here, and I got about 9 miles, 9.2 miles. So let's put that in here. So we're getting about 9.2 miles. And so our sinuosity for this river here, let's do the math here. It's going to be the 14.2 divided by 9.2. And so it's a 1.5. So I'll have to have some space here, but this is 1.5. So for this, I'll just put 1.5 here and circle it for this river here. And you'll see later on that you'll see that a 1.5 over here in this initial diagram, I show that sinuous streams are between 1.3 and 1.5, right? So this is a sinuous stream based on what we've seen with this river here. Now, the next question is asking us to measure the width of that stream. So what you want to do for that is just take your ruler and measure the width of the valley, because that's about the width of the stream valley there, of the floodplain, yeah. And then now we want to sketch a valley profile. So this one, what we want to envision, you can see that there's a valley profile and then there's a channel. And so what you want to show for this one, in fact, a couple things. We also want to show these upland regions up here where Weston is and Kickapoo. So you want to show that as well. So on our diagram, just a sketch of this, which would show we would have some upland. We'd go into the valley. We have the stream channel, the rest of the valley, and then the other upland. And so the water would be right here. And this region here would be the floodplain. This would be the upland. And then here is our channel. So those are all components that you need to write down. There's another upland up here. So that's the profile of the valley. And then for the Arkansas River, just as a comparison, you can see that here there's no floodplain. And this is going to be one of those V-shaped valleys, right? With this higher upland up here and then a kind of a steep gradient down to the river. So that river is going to look much like one of these early stage rivers with a V-shaped profile here. So on our map here, you're going to show an upland here and then a V down to the bottom of the river, sort of like that, and then up here, right? So up here, our water will be down here. This will be the upland, and the channel is here, right? And then now for the Mississippi, obviously it's going to be much wider floodplain. This one's going to have a meander belt. And so when you draw your profile for the Mississippi River, I want you to think about, this meander belt, right? So you probably want to draw those in and then show the back swamp, right? And then you would have uplands farther beyond that. Then you can answer these questions about the importance of downcutting and lateral erosion. And while you're at it, for this part of the lab, look at the Vicksburg, Virginia or Mississippi map and think about these meandering streams that are in the back swamp regions. And so for that, I want you to try to answer what these streams are in this, what are those called? And I have a special name for them. And so look at that diagram in the lab. That'll help you on that. And then there's a couple other questions about some oxbow lakes and kind of what's going on here. And then there's even one here on the Leavenworth. In fact, Mud Lake, I think we decided that was an oxbow lake, right? So you can add the answer to that. All right, well, let's stop here for now.